So here are the notes 1.4 for Honors Algebra 2. So your assignment tonight is basically just copy these down. So two objectives: be able to solve equations involving absolute values. Second one is be able to solve inequalities involving absolute values. So moving on. So we went over this in class. I'm going to go over this kind of fast. So the basic concept behind this is that we're doing the distance from zero. So this says the distance from zero of a number, we don't know what this number is equal to 3. So the visual concept is if we have a distance from zero, it has to be a distance of 3. So from zero, if you go this way, 3, we end up at the number 3. So that's one of our answers. So x can be a 3. Going the other way too, though, the distance on this side is 1, 2, 3, and you'll end up at a negative 3. So the answer to this is a positive 3 and a negative 3. Now the algebraic concept is this. The absolute value of what number is a 3? Well, the answer to there, you can kind of think of your own, is a negative 3 and a positive 3. Because the absolute value of a negative 3 would be a 3, but the absolute value of a positive 3 would also be a 3. So I know the stuff inside of here has to be both of these, basically. So that x, which is the stuff on the inside, has to be a negative 3 in order for this to be equal to 3. There's no solving involved, so that's it. Also, not only that, it could be x equals, ooh, that was weird, x equals a positive 3, because the absolute value of a positive 3 is still a 3. So put a little or in between there, and you are done. No other solving involved because the x is already isolated. Just a little side note, I'm actually not using the smartboard. I'm using a drawing pad thing. So if my writing is kind of sloppy, um, deal with it. So yeah. Okay, common method for solving absolute value equations. I say it's common because this is not the only way to do it, but this is one way to think about it that I'm showing you guys. So first thing is, so you isolate the absolute value. So if there's stuff, if you have absolute value bars, and then there's all kinds of stuff going on the outside, like a 7 there, or a 2 there, it stopped writing. Why? So it writes there. There it is. Okay. Oh, stopped again. Well, this is useless. Anyhow, let's erase that. So, if you isolate the absolute value first, if there's things on the outside of the absolute value bars, you need to, for lack of a better word, cancel them. After that, that's when you guys can split the absolute value into two separate equations and solve each of them, because you should have two answers, and then you solve each of those separate equations. Okay, so we did this in class, so just in case you want to see or hear how we did this again. So here we have the distance of this expression from 0 is 8. So the distance of this from 0 is 8. So this stuff has to either be a negative 8. Oh no. Why does it not write? A negative 8 or an 8. So those are the two things that it could be. Because the absolute value of a negative 8 is a positive 8, which is what our answer is, and the absolute value of a positive 8 is also an 8. So in math, we actually have a way of saying this. We're saying that this stuff, all of this stuff, has to be either a negative 8 or an 8. So in math, if we want to say if something is the same thing as something else, we can set up what's called an equation. So 6x minus 7, that's what this stuff is, has to be equal to a negative 8 in order for this statement, because an equation is basically a statement, in order for this statement to be true. And then you solve that. Or it could also be this positive 8. So 6x minus 7 can also be an 8. Oh, okay. So first step, add 7 to both sides. So you should have a plus 7. It's not a plus sign, that's a plus sign. Plus 7, so you get a 6x equals negative 8 plus 7 is a negative 1. Oh my goodness gracious. Hold on. Okay. Here we go. Okay. So we got a 6x, and then those turn into a 0. 0 plus anything is the same thing. Negative 8 plus 7 is a negative 1. That's a 1. All right. So 6 times x equals 1. So opposite of multiplying, inverse operation of multiplying is division. That's a 1, not a 4. So we got it x equals negative 1/6. And that is going to bother me a lot. So hold on. Pause. Okay. So I'm trying something different now. Hopefully this works. So let's erase that. Let's make that a little nicer. Okay, nicer. 1 divided by 6. That's 1/6. That's one of your answers. Other side, we're going to add 7. 7s are gone, or 0. 6x plus a 0 is still 6x. Equals 8 plus 7 is a 15. Devote, divide both sides by a 6. X equals, and this does simplify. It simplifies with a 3, so that's going to be a 5/2. A little or in between. Some teachers make you circle the or. I'm not that picky. So next one, scroll up. Okay, so this side can be either a same thing. This stuff on the inside is its distance is a 21. So the stuff on the inside is either going to be a negative 21 or it's going to be a positive 21. So all we're going to do is, there's nothing on the outside of the parentheses, if you can kind of see that. We're going to split it. So it's going to be 5x plus 9 equals a negative 21, or a 5x plus a 9 equals a positive 21. All right, so the next thing is we're going to subtract 9. 5x is equal to negative 30. And then we're going to divide by 5. So x is going to be equal to negative 6. Okay. Yeah, that's right. Okay, so minus 9 over here, minus 9 over here. 9s are gone, or they're still there, but they're 0. So 0 doesn't really do anything when you're adding. 21 minus 9 is a 12. Okay, divide by 5. So x is equal to 12 over 5. All right, put a little or in between, and like I said, if you want to circle the or box the or as part of your answer, you can. If not, you don't have to. And moving on. Okay, this we do. I think I did that with some of you guys, but we'll go ahead and skip over it just because it's like the other ones, so this isn't really necessary. This one I do want to do with you guys. This one is different. If you'll notice, it's different because we have stuff on the outside of the absolute value bars. So if you were to actually read this out, ouch. If you read this out, this would say 2 times the distance from 0 plus 5 more is equal to 35. So that statement's too long in of itself, so I don't want to solve it with all that stuff on the outside. So what we want to try to focus on is we're trying to get this statement to get down to saying the distance from 0 is a number. So these numbers on the outside of the absolute value bother me. So I need to use inverse operations to make them not bother me anymore. The way we do that is order of operations. We do it in reverse, so we should get the adding and subtracting taken care of. So plus 5, you're going to subtract 5. So we're actually starting the solving steps. So this is 2 times the absolute value of 6x minus 3 is equal to 30. All right, so now we got a statement that says 2 times the distance from 0 is 30. That's still too much. Now, I know that a couple of the students said, how about we distribute it in which case you can, but I'm not going to use that method to do it, and I already said why in class. We're just going to keep solving here. Let's go ahead and do the opposite operation of multiplication because it says 2 times, so we're going to divide by 2 on both sides. 2's are now 1 equivalent, so it's going to be 6x minus 3 is equal to 15. All right, at this point, now we have an equation just like the ones we did on the other problem. I'm going to go through this kind of fast. So this stuff inside can either be a negative 15 or a positive 15. So what we're going to do is we take the stuff inside of the absolute value and say, okay, that expression, 6x minus 3, has to have a value of negative 15 in order for that to work. Or the 6x minus 3 expression has to have a value of a positive 15 because Absolute value positive 15 is 15 also. And then just solve out from there. Now, when I do dot, 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 it's basically so that I can save time, and you guys are the ones that need to finish that off. So when I go around tomorrow and check your notes, I should not see dot, dot, dot. That's basically you should solve it out on your own and get an answer. Okay, but that's just two-step solving equations, so you should be able to do that. Going on the 10-minute mark. The reason why I do that also is I'm trying to keep this under 15 or 20 minutes. So get that done. Okay, pair share. Let's go ahead and skip over that one. Okay, so we're to inequalities now. All right, so common method of solving absolute value inequalities. Very similar to the way we did the other one. Isolate the absolute value first. Split the inequalities, split it into two inequalities, similar to how we solve the equations. Solve each of those, and then graph it. Now, from the graph, you will know if it's an and or an or conjunction, or I actually think or is called a disjunction. But yeah, whatever. So don't put the and or the or part until after you graph it to make sure. Now, if you can memorize it in another way, I'm okay with that. You can do that. But yeah. And Aguirre do. So none of the classes made it this far. So this is new notes for everybody. All right. So what this is saying is the absolute value, so the distance from 0 has to be smaller than 21. So that means that your distance is going to be less than 21. You know what? Let me explain this another way. Okay, so new page. So take notes on this. So if you have the absolute value of x is less than, let's say, a 5. Okay? So what this is saying is the distance from 0 is smaller than 5. Now, visually speaking, if we have a number line and we have 0, now we know that the key thing here is that number 5 right here, right? So let's say the distance from 0 is 5. So 1, 2, 3, 4, 5. That's the distance from 0 is 5, so we'll end up at the number 5. Or we can go to the left, 1, 2, 3, 4, 5, or negative 5. So the absolute value of x is equal to 5 would be at 5 and negative 5. But the thing here is it's saying the distance from 0 is smaller than 5. So if I look at 0, I can see the distance from 0 is 5, but I want smaller than 5. That's everything right here. Because this, so say it's a 1. At 1, that distance is smaller than 0. I'm sorry, smaller than 5, which is what it wants. So I actually have all of these numbers are a distance smaller than 5. But not only that, everything on the left side is also smaller than 5. Okay, that actually sets up two separate inequalities related to the negative 5 and the 5, because the distance smaller than 5 is everything in between here. So it can't be 5 itself. So that's means it can't touch 5, can't touch 5, but it includes all of these values in between. That should look familiar. That's a and compound inequality, okay, because it's shaded in between those 2 points. So it turns out when you have your values less than that symbol, that's going to be an and. But it helps to see the graph, because once you see the graph, you'll know. All right, so now that I said that and bored you very much, let's go ahead and do this one. So this one says that your distance from 0 is smaller than 21. So that's going to be everything on the inside. So I already know that it's an and. But let's assume that you don't know that. Okay, so we're going to do this the same way. There's nothing on the outside, so it's going to be a negative 21 and positive 21. So we're going to have a 4x minus 9 and a negative 21. 4x minus 9 and a positive 21. Now you will notice that I didn't put the actual symbols in. The reason being is, on the positive part, the symbol stays the same. Okay? Because you want your value, your distance from 0 should be smaller than 21. But at the same time, it's going to be bigger than 21 on the other side. So it's going to be greater than or equal to. So you might notice that you flipped the sign over. Okay? Just to kind of show you why we did that. Here's 0. Say this is 21. Say this is negative 21. I want the distance from 0 to be between those two. That means it's everything up to and including those. Okay? So that means that the shaded part right here, that's greater than negative 21, because it's up to the right of negative 21. That's how this one came about. is because this shaded part is greater than 21. But then at the same time, this other side is smaller than 21. So that's why it's still smaller than positive 21. Okay. So a kind of quick way to memorize that I've heard some people say is that when you turn this part negative, which is over here, just make sure that you flip the sign over when you turn it negative. And then when it's positive, the inequality symbol stays the same way. Okay. So that's the reasoning behind it. All right. So get all this stuff off of here. And we can get, oh wait, I don't want everything gone. Ah, oh well. I'm gonna spend 10 minutes just erasing. That's not good. All right. Oh, wait, I can do this way. No, not that. Aha, there you go. All right, so let's solve this. So plus 9 plus 9, you need a 4x is greater than or equal to 9 plus a negative 21, and that is the bell, okay? 9 plus a negative 21, hold on. All right, oops, I got my pin across the classroom. I promise my YouTube videos will be more organized after this one. Okay, so negative 21 plus a 9, you're going to subtract those, so that's going to be a negative, whoa, why did that eraser show up? Negative 12. All right, divide both sides by 4. You should get x is greater than or equal to a negative 3. Just a little side note too, if you happen to catch me making a mistake on here and you spot it and show me tomorrow, I do give extra credit because Mr. Aguirre, even though I've been teaching math for a long time, I'm still human and I still make mistakes. Okay, so 4x is less than or equal to 9 plus 21 is a 30. So divide by 4. Divide by 4. So x is less than or equal to 30 divided by 4. That's going to be a 15 over a 2. All right. So down a little. So right now, if you still don't know what it is, all you got to do is make your number line, make your marks. Which one is smaller? Figure that out, and then that's the number that goes on the left. Negatives are always smaller than positives. So the negative 3 will go over here. Positive 15 over 2 goes over here. Okay. Both of them are closed because they can be equal to. It has to be smaller than 15 over 2, but at the same time bigger than negative 3, so it is in between. So you can write the word and, since you know it's in between, and then box your answer. Another way that you may see your answer, and I would actually suggest you write your answers, is when you have an and compound inequality, you put the x in the middle, put the bigger number to the right, put the smaller number to the left, and then fill in your inequalities accordingly. X should be bigger, it's equal to, less than or equal to this side, and there you go. Both of these are technically right. The one that I wrote in green is normally how teachers want to see it though, okay? But actually in my class I'll accept either one, but do be aware that both of these are acceptable. So in a multiple choice test, if we're doing this and you only see this one, you need to make sure that if you're used to seeing it this way, that you can turn it into this format, this form right here. All right, and that's how you do that one. Let's do one. Let's do this one. So if you notice, this one is pointing the other way. Yeah, so we're going to go over the 20-minute mark here, but that's okay. So this one, same thing. We know that stuff inside of here, we can do it just like how we did the equations, negative 18 and positive 18. So like I was saying before, I will draw this just so that you can see it. This is saying that the distance from 0 is bigger than 18 units. So here's 0. Let's say 18 is here. Let's say negative 18 is here. So we want the distance to be greater than 18 units away from 0. So if you notice, there is not an equal to, so it will be open circles at these. Now, in order for the distance to be bigger than 18, it has to be beyond 18 to the right and beyond negative 18 to the left. So for example, this is negative 19. that distance is bigger than negative 18 from 0. Okay, so that's what this is saying. Um, you don't have to draw that. That's just to help you guys realize what this statement is saying. So now, just like with the equations, we're going to take the expression inside of the absolute value. We're going to set it to both of these with inequalities. So what you're going to do is you can take 3x minus the 2, put the negative 18. So you can either look at that graph that I just drew and then and then know that it should be less than negative 18, or you can just think, okay, that 18 turned negative, so I got to flip the not the absolute value, I got to flip the inequality over. Okay, so basically what I did is I took this, flipped it over because I took this, and then I flipped that too. Okay, all right. So let's take those off so they don't get mixed up with other things. Now, so don't put and or yet. So we got a 3x minus, why is it still red? Okay, 3x minus a 2, and then the inequality symbol stays the same because that's still positive 18. I did not switch the sign. All right, so let's solve both of these. So plus 2, 3x is less than negative 18 plus 2 is a negative 16. Then we divide by 3. X is less than, that does not simplify, so negative 16 over 3, leave it like that. Other side, do it in red, plus 2, 3x is greater than 20. Divide by 3, x is greater than, that does not simplify either, so that's going to be 20 over 3. All right, so now in order to figure out if this is an and or an or, because I still got to put the word and or in between here, let's go ahead and graph it. Oh, I didn't mean to push that. I want a nice, neat line. So Mr. Aguirre is going to cheat and just use a nice, neat line. Okay, so let's say that's the bell again. Let's say this is, oh wait, we don't need that in the middle. I told you guys you can just do 2 marks. I'm okay with that. So the smaller number is always a negative one, 16 divided by 3. If you're not very good with that, feel free to turn it into a mixed number or decimal to help you realize which one is a smaller one. Negative 16 over 3. This is going to be 20 over 3. All right, so they are both open. Should be smaller than that, so it should go this way. Should be bigger than that other one, so it should be going this way. That indicates this is an or. And there you go. Yay. So when you have absolute values of inequalities, you actually end up with a compound inequality as an answer. All right. And it's a pair share. So let's do this one. All right. So I'll do this one. Keep in mind tomorrow will be a work day in class. So I'm going to be giving you guys a worksheet that has these types of problems on there. I'll be coming around and helping you while you're doing these, so make sure you review these notes, okay? All right, so got a problem here. Problem is I have a number outside of the absolute value bars. So this actually says negative 9 times the distance from 0 of an expression is less than negative 54. Now this is already looking kind of weird because we got a negative on this side. Normally when you have an absolute value, you have a positive here. But it's okay because we have a negative 9 here. So we're going to get rid of that 9 by, this is multiplying, we will divide. So let's divide by a negative 9. Divide by a negative 9. That's a 1. So 1 times anything is the same thing. Now remember, when you divide or multiply by a negative, the inequality is going the other way. So 9 divided by, or 54 divided by 9, let's see, 45 is 5, so it's a 6. All right, and it is a positive. So what we do now is, this could be, let me change colors. This could be a negative 6 or it could be a positive 6. Now that the absolute value bars are isolated, we can go ahead and split it into 2 inequalities. So it's going to be the negative 8r plus 6 with a negative 6. Since that sign changed, I'm going to go ahead and flip the inequality over. Negative 8r plus 6. Since that is a positive 6, the inequality will stay the same there. So you should have on the negative side, it flips over. On the positive side, it stays the same as the original. Okay? Just double checking my signs here. Okay, so let's do a minus 6, minus 6. Negative 8r is less than negative 12. So we're going to divide by negative 8. There's another sign flip there. Let's extend the page. So those are gone. R, this, make sure you guys take that and switch it. You divide it by a negative. 12 divided by negative, negative is a positive. That can be simplified by a 4, so that's going to be 3 over 2 positive. All right, minus 6, minus 6. Negative 8r is greater than, that's going to be a 0, divided by negative 8. Divided by a negative means that this symbol will turn over, so it turns the other way. 0 divided by anything is a 0. All right, got to figure out if it's an and or an or. So what's smaller, a positive number or a 0? I would say a positive number. And open circles because it is not equal to. Your r should be, your variable should be bigger than 3/2, but at the same time it should be smaller than 0. That is bigger than 3/2. This way is going smaller than 0. That looks like it's an or. That's a lot of r's and o's. And that is it. Congratulations, you made it through your first YouTube notes with Mr. Aguirre. And you did it in 27 minutes and 8. Oh, wait. Whoops, wrong button. Yeah, so 27 minutes, 18 seconds. Okay, bye-bye.